So, what's the title today? We played a little bit on words, but it's ramping up for complexity management. Modern designs are getting more complex. How do you ramp up, especially for certain designs that we do in the U.S. government in support of U.S. government as DoD? That's the key challenge here. And RAMP is Rapid Assured Microelectronics and Prototyping program that was funded by the Office of Undersecretary for Defense, Research and Engineering, and we'll talk about some of our experience using this ramp mechanism a bit. Who's BAE? We are a premier company servicing the U.S. national defense requirements and some commercial operations here. We have a lot of heritage with our products flying out to Mars and beyond. We have been producing space rad-hard electronics out that go out and have been flying in the Voyager series out in the far edges outside the solar system. We also have a lot of other types of products that we do custom microelectronics for. We're spread around the nation. All the good stuff that's required of a defense company out here. What is our current infrastructure? Obviously a lot of internal support based like any other big company in general, but DoD environment is a little bit more tighter, more compliant driven, more security oriented. It's got a lot of the same issues around what you have for network access, network space, disk space, all of that. You want to have a grid support for running the farm-based simulations and or jobs that you want to do. On the business side, you have to have government compliance, contracting languages, legals, terms and conditions, NDAs with multiple parties, probably a little bit more than what commercial ends up doing, but has to happen. It's a lot of ticket-based systems because it's a large organization, not a smaller startup company where things get done by the, hey, hello, can a Slack channel approach. You have to do a lot of overhead there. And basically, it's a lot of overhead governance issues there. But it comes with a support cost and has challenges when it scales the complexity level. BAE Systems was one of two performers in the RAMP pilot program. We did two chip designs. One was on GlobalFoundries 12 nanometer, and another one was on Intel 16. Fairly large sizes, about 64 square millimeters and about 32 square millimeters on Intel 16 mixed signal design with varying proportions of high-speed designs essentially being done there. Physical implementation was done on the cloud, on a Microsoft Azure cloud with help from ClearSoft or Keysight, ClearSoft data management solutions, which you probably have heard of it as SOS in its current and previous forms, essentially. We had a very stringent timeline to achieve what we needed to do. Normally, it takes about 12 to 18 months to get a rev out. We had to do it ASAP in 10 months, which is where cloud comes in as a accelerant. So it's an on-demand environment from Microsoft Azure, and we'll talk about that a little bit. The Microsoft on-demand environment really provided, the key thing was, it was built on the concept of trying to get security, security, and more security as the key thing that's required and be gov compliant. IP for a defense article is very, very sensitive, so we have to handle that appropriately and where we want to do about that. How you handle that, how you provision that, all of that's an important piece. And cloud computer security always is not something that a defense company will always accept very easily, whatever you do, because it's just the nature of things. But I'm sure it's the same thing with all other companies, even in the commercial world. Your IP is your king. You want to audit and you want to make sure it's protected. We've all heard of data breaches and other kinds of actions that from potential adversaries, whether it be other commercial adversaries or nation state, however it be looked at, that's an important piece. We also felt that Microsoft Azure was building its foundations for an easy collaboration with partners, making sure multiple players come together, and it was a fully managed service at its heart. Essentially, Microsoft is trying to create what is a very challenging task to be providing a secure, government-compliant cloud development environment for complex IC design and associated workloads in building that particularly. I won't go into much of the details of all the pictures here essentially but how do you transition to the cloud? Obviously, every company will go through its own nuance in a commercial setting or even in a defense setting, it's even more challenging, is you have a lot of different homegrown tools, capabilities that have to be ported and used. There's decades sometimes of worth of knowledge and experience depending on the tenure of people and the types of designs and sustainment that you end up doing. There's a lot of history and information that's set there that we have to maintain and be able to access on a very quick notice. There's also perceived risk in any one of these situations. Perception is 70% reality maybe, or 80% reality, but so you have to deal with the perception, you have to walk through, everybody has to go through. It's like, it's very difficult to run a marathon, but once you start running and practicing, it's sort of the wave you generally get through. Cloud is a very good option if you are testing out areas. You may want to do some things in cloud on a hybrid mode, so you could do large job batches, simulations, and or LVS DRCs. Simulations have a little bit of a challenge potentially if you want to download stuff afterwards for debug. You have to think about some of those things. From an IP management system, depending on how many designs you're doing, the same version of the IP, not the same version, a IP could have multiple versions going in different products depending on what maturity level or what feature you want to have or what bug fix you're doing there. So those have to be considered. That's where an IP management system and design management system is useful. And there's always high security requirements that you have to think about, be it commercial, be it defense or gov activity that we have to think about. What is the future of cloud computing? This is not the Microsoft booth, this is Keysight booth, but still it's important to have a perspective of what is important to the gov cloud is working with partners, creating the collaborative environment to be able to pull in all the data to make sure that we can accelerate the dev of a complex IP or design that services national security needs or critical infrastructure. You always ask the questions around what's the type of security? Is it provable, attestable? How do you have the day-to-day challenges of, hey, I have to package a test case. I can't share it with an AE who's not cleared or is able to get in there. How do you siphon off just the portion that they need to see it, not everything else? All of those kinds of considerations have to happen here. But cloud computing can enable provision with the right set of solutions put behind it, can enable a very collaborative and scalable solution in a high secure environment, both for not only for government users or government applications, but also for companies with valuable IP that they want to differentiate very specifically. So let's get comfortable with the cloud if it's one way to say it. But resolving in some of these areas and working as an industry together, it only allows us to scale capabilities and really bring a set of acceleration to what we need to be doing in terms of IP reuse, IP leverage, collaborative work, and sharing of the data and systems that we want to build and the complexity that we want to build. So I think I would leave at this point. I think that's probably the last slide. And at this point, I'm open to questions on our experience and what may be our challenges or what we experience. So
the question is, what kind of tools do you have to manage the complexity of a modern design, and what kind of designs are you doing?
So I think great question. On the previous slides, just before we talked about, we have requirements management. You have your spec management, which is slightly different from requirements management. You have feature management, you have configuration management, you have time enclosure, RTL, bug fixes, reports, progress reports to be given. You have all these kinds of challenges that are 17 dimensions and 14 program managers and 12 engineering program managers who are trying to collect all this data and stuff. So one is the complexity of just the set of activities that you have to go through the entire aspect. Beyond that, you have, in a modern complex design, you'll have, hopefully, if you're doing it good, you're doing it tens of pieces of complex IPs, each having sub-IPs or sub-assemblies in itself, so to speak. You could have a processor configuration, you could have a whole I/O complex that's completely different, you can have a DSP complex in itself that's completely different, test, validation, reports. Beyond that, and just IP, if I were to look at it, just making sure that everybody's on sync with the same version, getting to know, even before the IP is ready, if it's commercial IP, hey, what's the update with legal? Where is contracts at? Did you signature this? What is the cost of the royalty? Where is the documentation kept? Oh, it's in 7 different places, and each one is managed by a separate person. I cannot see what you want to see, or I won't let you see what you cannot see. All those kinds of complexities come into this place. So even thinking about that, Excel has grown to be the tool for everything, but for finance probably. It's used for project management, to scheduling, to whatever you want, label makers, I think. But the complexity is mirrored in its nature of what we have across the tool set and hierarchy.